So we've treated laws of indices. Now we want to treat another law, raising a power to another power. Okay, what does this law entail? This law makes clear that a base in a bracket with a power can have its power to multiply another index outside the bracket. Take note of the sign. Plus times minus minus, minus times minus plus, plus times minus minus, minus times plus minus. Take note of the signs. For this example here, we have minus, and then this is plus, and this is plus plus. So, let me quickly explain. When we have a as the base raised to power 3, and then there's an index of 3 outside the bracket, the law says let the power of this base multiply the index outside. So that means 3 will multiply 3. Same thing goes here. A raised to power 2 into bracket, then 6 outside the bracket. So it's going to be a raised to power 2 times 6. Same thing goes here, minus 3 times 5. So let's work it out. So when we have a, write it down. Then we're going to have 3 times 3, like this. So that means this is a raised to power 9. Second one, a raised to power 2 times 6. So it's going to be a raised to power like this. Then 2 times 6 is 12. That's a raised to power 12 as our final answer. Then thirdly, we have a raised to power minus 3 in brackets, close brackets. Then we have 5. So 3 times 5 is 15. So I wrote it here, a raised to power what? Minus 15. Remember the fourth law I treated with you, inverse, where I said when the index of a base has a negative sign, then it makes the base to become the denominator. And in some cases, we flip the position from denominator to denominator, or from numerator rather to denominator. So in this case, the base here is a numerator. So we flip like this. So to remove the negative sign, we say 1 over a raised to power 15. When we say 1 over, we have changed the position from numerator to denominator. So in that case, the negative sign has to go. Let me show you something quickly. Let's say we have 4 over, okay, don't worry, let me not take it far. Let me just stick to this video so that we can quickly solve this. Let's quickly solve this. I believe during the course of the lecture, I'll still make my points, so let's not deviate. So the first one here, I have 3g, and then into bracket square, then another bracket, then we have what? Minus 2. So the first thing you need to note here is that this minus 2 here belongs to 3g. Sorry, this 2 here rather. Why this minus 2 belongs to everything? Okay, so all I need to do is, since this 2 belongs to this and this, I'll remove the bigger bracket first. So let's start with the bigger bracket. So 2 times minus 2 is minus 4. So I'm going to have 3g minus 4. Do you get that now? Do you get that? We remove the bigger bracket. Now, is there anything we can do to work this out? Of course there is. Alright? All we just need to do is, without wasting time, I'll just do 1 over 3g raised to power 4. I don't think I can simplify this more than this stage, because if I do 3 raised to power 4, that's 3 times 3, 9, 9 times 3, 27, 20, like that. And then g raised to power 4, it will still give me something like this, 1 over 3, 4, and then g4. So, and this is the best way to simplify it. So I'll just leave my answer like this. Let's go to the second one. Now, if you notice, when I wrote this question, I observed something. Then I quickly say, let me asterisk it so that I'll tell you during the course of the lesson. Odd and even. See, when you are dealing with the powers, you need to be very careful with the result. If it is odd or even, you need to be very, very careful. When there's a negative sign on the base and you want to raise the power, remember that the power here belongs to both 2 and 6. Oh, I didn't give you that example. That's true. If I have a raised to power, let's say 7, b raised to power 2, all in brackets 4. Or let me just say all in brackets 2 to make it faster. Please, when you want to open these brackets with this index, it's going to be a raised to the power 7 times 2 and b raised to the power 2 times 2, making it a raised to the power 14, b raised to the power 4. Do you get that now? It has to, the index here will affect every of the bases inside the bracket. So for this question, we have two bases here. We have 2 and x, minus 2 rather, and x. Now, this is even. Let us solve. So I have minus 2 x raised to the power 6 into bracket 4. So let's simplify. So that means it's going to be minus 2 raised to the power 4 x. How did I get 4? Sorry, yes, now the power of 2 here is 1. Okay, let me just show the workings. Minus 2 raised to the power 1 times 4, and then x raised to the power 6 times 4. Where did I get this 1 from? When there's no base, when there's no index written, there's 1 there. Okay, so that means going to have minus 2, 2 raised to the power 4, 1 times 4 is 4, then x raised to the power 24. Is that clear? So this is minus 2 raised to the power 4. Take note, this is a law in mathematics, general law. When the base has an even index, the minus sign will go. Let me give you an instance of what I'm talking about. If I say minus 5 raised to the power 2, if I say minus 5 raised to the power 2, I hope you know it is minus 5 times minus 5. I hope you know. Good. So since you know, that means minus times minus will be plus. 5 times 5 will be what? 25. Do you get that now? 25. So the law says when the index is even and the base has a negative sign, the minus sign is eliminated. It's not magic. It means minus times minus. So the same thing goes here. Same thing goes here. Okay? So since this minus 2 is in 4 places, just like, let me be practical with you. Minus 2, minus 2, minus 2, minus 2. So if you group like this, you notice minus to minus to give us plus, minus to minus to give us plus. So our final answer will not have the negative sign. So it's going to be minus 2 raised to the power 4. Sorry, plus. Let's even expand it. That's the only way. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So our final answer is 16 x raised to the power 24. For the sake of this video, I'll come back. I'll make another video to solve the last one.